Okay, like I said, I think you're going to like today. Today the method is, to me, is very cut and dry. It's a method called reduction of order, if I could spell it. All right, reduction of order. All right, what's going to happen is they are going to give you one solution. They're going to give you a y sub 1. It is one solution to the differential equation. And they're going to ask you to find the other solution. So we are going to find y sub 2, which is another solution. And the way you do this is you make a substitution and the substitution is going to be for you to set y equal to u times your y sub 1 times the given solution. You're going to take derivatives of this and then you're going to substitute it into your equation. All right, so let me just kind of show you what it looks like. And what you do is once you do all the substitution, you should get an equation that is linear in form. And you're going to find the integrating factor and multiply through and do all your integration. So let me just look at an example. This is number 6. The differential equation is y double prime minus 25y equals 0. And the y sub 1 that they give you is e to the 5x. And they are asking you to find the second solution. Okay, find the y sub 2. So you take and you set y equal to a function of x, u, times e to the 5x. Then you're going to have to substitute this into your equation, so you need to take the second derivative. So I need y prime. All right, u might be a function of x, so you're using your power rule. So this is u prime e to the 5x plus 5u e to the 5x, first derivative. The second derivative, you take the derivative of this, you've got to do the product rule again. So this is u double prime e to the 5x plus, all right, the derivative of the second one is 5u prime e to the 5x. The derivative of this is 5u prime e to the 5x plus the derivative of e to the 5x is going to be 5 times 5. That's 25 u e to the 5x, which is, you should have like terms here that you can add together. This is u double prime e to the 5x plus 10u prime e to the 5x plus 25u e to the 5x. And that is y double prime. Take as many derivatives as you need to put it in the equation. Everybody okay with my derivatives? I'm using product rule. First derivative, second derivative, first. Okay. So now substitute into your differential equation. Y double prime. That's u double prime e to the 5x plus 10u prime e to the 5x plus 25u e to the 5x minus 25 times y, and y is u e to the 5x, and that is equal to 0. So all I did is substitute. Into there. All right, simplify this as much as you can. These two are going to zero out, and I'm left with u double prime e to the 5x plus 10u prime e to the 5x equals 0. Okay, everybody with me? This one is supposed to be linear in form. But if it's going to be linear, you have to divide by e to the 5x because you have to have just u double prime here. So dividing everything by e to the 5x. That cancels out, and you're left with u double prime plus 10u prime equal 0. And this is actually linear in u prime, not in u, but in u prime. So we have to find the integrating factor. The integrating factor is e to the integral of 10 dx. So the integrating factor is e to the 10x. Then you're going to multiply by e to the 10x. E to the 10x times 0 is still 0. Okay. By definition, multiplied by the integrating factor. When you integrate this side, this is the integrating factor times the other variable. The other variable is u prime. So u prime equal to the integral of 0 is some constant, call it C1, because you're going to have a couple of constants in here. Now I've got to solve this thing for u prime because I've got to integrate this thing one more time. So get e to the 10x on the other side, and that would give me u prime is e to the negative 10x times c sub 1. Now I'm looking for u because I've got to go back up here and put u back in this expression. So to get rid of the u prime, I'm going to integrate both sides. The integral of u prime is u. The integral of this side is, it's going to be c sub 1 over negative 10, which is just going to be another constant. E to the negative 10x plus c sub 2. So u is c1 e to the negative 10x plus c sub 2. Y'all with me? Assuming I did that right. I just made this another constant. I called it C1. It's really not C1. It's really a C3, but it's just another constant. So now you take this u and you go all the way back up here and you substitute it in. So y is now e to the 5x multiplied times what you had for u. Go ahead and distribute this because you're going to have to read your answer. So this is going to be c1 e to the negative 5x plus c2 e to the 5x. This is actually the general solution to your whole differential equation that you started out with up there. Oh, you can't see that, sorry. This is the general solution to the whole problem. But I haven't answered the question. So are y'all with me to this point? All right, they asked me to find my second solution. So if you'll remember, the first solution they gave me was e to the 5x. Well, e to the 5x, that's right here. The other solution is this one. The other solution, the y sub 2, is e to the negative 5x. It's the one that doesn't match what you were given. So this is the second solution. Because if you remember all that theory from the other day, if you know two solutions, then the sum of those two solutions is also a solution. So right here, and this is the answer to the question. All right, so you always make the same kind of substitution. Okay. All right, let's look at one with the trig function in it. And then we'll look at one that is not homogeneous. These are all homogeneous equations. number 4 has got a trig function in it. 4 is y double prime plus 9y is equal to 0. And the solution they give me is y sub 1 is equal to the sine of 3x. And again, they're looking for the second solution. What is y sub 2? So you have to make a substitution. Set y equal to u times the sine of 3x. Then you've got to take the second derivative to put it into your equation. So first derivative is u prime sine 3x plus, now the derivative of the sine, that's going to be 3u cosine of 3x. Second derivative, u double prime sine 3x plus the derivative of this is 3u prime cosine 3x. Then the derivative of this, 3u prime cosine 3x. The derivative of cosine now, that's going to be negative 9u sine of 3x. And something should add together. This does. So y double prime is u double prime sine 3x plus 3 and 3 is 6 minus 9u sine of 3x. Y'all all following my derivatives? Okay. Once you get all your derivatives, substitute in. So now substitute u double prime sine 3x plus 6u prime cosine 3x minus 9u sine 3x plus 9 times y, so that is 9u sine 3x equals to 0. Oops. Substitute and simplify. That's going to zero out. And I have u double prime sine 3x plus 6u prime cosine 3x is 0. At this point, y'all with me? All right, we've got to divide by the sine of 3x because we can't have that there. So that's u double prime plus 6u prime cosine of 3x over the sine of 3x equals to 0. Yes, cotangent. All right, remember this is linear, so you have to find an integrating factor. So your integrating factor is e to the integral 6 cotangent 3x dx. So what is that going to be? E to the 2 natural log sine of 3x, which is the natural log sine of 3x squared, which means my integrating factor is sine squared of 3x. And I see y'all didn't pull your calculators out, so you are trusting me that I typed it in, right? And I hope I did. All right, so this is our integrating factor, so we're multiplying everything by your integrating factor. So sine squared 3x u double prime plus 6u prime. Cotangent now is cosine over sine, so one of these sines is going to cancel with this one. So you're going to be left with the cosine of 3x multiplied times the sine of 3x equal to sine squared of 0 times 0 is 0. Cotangent, remember, is cosine over sine. That sine cancels with one of these when you multiply it through. All right, when all is said and done, if you integrate this, you should get the integrating factor, which is sine squared of 3x, times the other variable, which is u prime, equals to a constant. I'm integrating both sides. So now I've got to divide by sine squared. I've got to get u prime by itself. So u prime is going to be c sub 1. 1 divided by sine squared would be cosecant squared of 3x. You can leave it as 1 over sine squared. That's fine. Because now you're fixing to integrate this. And again, I don't see you guys pulling out your calculators. You're going to trust me on this. Okay. The integral, because I don't remember what the integral is. The integral of I'm going to call this a C. I'm combining some constants, and I'm going to get cotangent of 3x plus c sub 2. I got a negative 1/3 in front of that, but I just combined it with my other constant. Are y'all good with that? All right, that's u. So now I have to go back up here to get y. So y is the sine of 3x multiplied times u, which is c sub 1, cotangent of 3x plus c sub 2. So y is c sub 1 when you multiply sine times the cotangent times the cotangent of theta. Remember, that's that's sine theta multiplied by cosine over sine. Those are going to cancel and leave you just with the cosine. So when I multiply here and here, I'm left with the cosine of 3x plus c sub 2 times the sine of 3x. And again, this is actually the general solution to the differential equation that they gave us up there. But it is not the answer to the question that they're asking you on my WebAssign. They're asking you for that second solution. And in this case, since they already gave us the sine as one of the solutions, the second solution is the cosine. So the y sub 2 that they're asking you for is the cosine of 3x. That is your second solution.
Why don't you keep the C1 with it that you just don't?
You don't. No. You just don't. Because they're asking you for the second solution, and if you put the C1 in front of it, you're telling them a family of second solutions. They don't want a family. They just want to know what is it before you multiply by the constants. Okay. All right, then the other type problem that you have in here is a problem that is non-homogeneous. And they are going to ask you in here, if you'll remember from the lecture the other day, if you solve a non-homogeneous equation, you get the solution to the homogeneous equation plus a particular solution. So if you solve a non-homogeneous equation, you get it in the form y sub c plus y sub p, where this is the general solution to the homogeneous equation, And this one is a particular solution. To the non-homogeneous equation. So in a problem like number 19, it is non-homogeneous. They have y double prime minus 3y prime plus 2y is equal to 5e to the 3x. And they give you y sub 1 is equal to e to the x. They are asking you in this problem to find y sub 2, like we did in the other one, but they're asking you to find one more thing. They're asking you to find the y sub p. But the steps are exactly the same. It's just when all is said and done, you just look at your expression and find your other solution and your particular solution. It all comes out, okay? So you start exactly the same place that you did before. By the way, how do you know this is non-homogeneous? Do you remember the definition? Right, that's not a zero. It's non-homogeneous. All right, so you start off just like we did before. We're going to set y be equal to u e to the x, and we're going to take our derivatives and put them in here. So y prime is u prime e to the x plus u e to the x. Y double prime e to the x plus y prime e to the x plus the derivative of this, I'm saying u prime, sorry, e to the x plus u e to the x. So y double prime u prime e to the x plus 2u prime e to the x plus u e to the x. Again, everybody okay with the derivatives?
Did the second derivative cancel?
I added these two together to get that. Nope, I left off my little tick mark. It didn't cancel anywhere, sorry. There should be yeah. In my brain I had it written there, sorry. Pencil just didn't cooperate. Okay, so thanks. Now I'm going to substitute. U double prime e to the x plus 2u prime e to the x plus u e to the x. All right, minus 3 times y prime, which is u prime e to the x, plus u e to the x, plus 2 times my y, equals 5e to the 3x. Now I'm going to go through and distribute and add my like terms. And some more stuff should cancel out like it has before. Alright, so this is negative 3u prime e to the x. This is negative 3u e to the x. And this 2u e to the x is 5e to the 3x. And what's going to subtract? U and u, that's 3 minus 3. These two will add together, and I have u double prime e to the x. 2 minus 3 is minus 1 u prime e to the x is 5e to the 3x. So these canceled out and these two added together. All right, this is still supposed to be linear, so divide by e to the x. So u double prime minus u prime is equal to 5e to the 2x when I divide everything by e to the x. Okay, integrating factor. E to the integral, all I have here is a negative 1, so negative 1 dx. And that is e to the negative x is my integrating factor. So now multiply by e to the negative x. All right, negative x, and 2 is going to leave me with just 1x, I believe. All right, next step. If we did all this right, this is supposed to be the integrating factor times our other variable, which is the u prime, equal to, we have to integrate e to the 5e to the x. The integral of that is 5e to the x plus a constant c sub 1. Solve this for u prime. I would probably multiply by e to the x. That's going to be u prime is 5e to the 2x plus c sub 1 e to the x. You're with me at this point. Take it like we did before and go, oh, we've got to integrate. Sorry, we hadn't integrated yet. So now integrate to get u. The integral of this, 5e to the 2x, is going to be 5/2 e to the 2x, plus the integral of this is c1 e to the x, plus another constant. Now, after you've integrated, now you go back and you substitute in to your y equation. So it's e to the x times y. Multiply by e to the x. So this is 5/2 e to the 3x plus c sub 1 e to the 2x plus c sub 2 e to the x. And that is the general solution to the non-homogeneous equation. This is the general solution. Alrighty, the one they gave you was e to the x. So this one was the first one they gave us. Out of these two terms that are left, which is the other one? Which is the y sub 2? Right, it is this one, the e to the 2x. It's the one with the constant in front of it. The particular solution will not have a c in front of it. The y sub p is 5/2 e to the 3x. Okay. If all is said and done, if you get down here and you don't have your original solution in what you did, you made a mess somewhere. Go back and check your signs, your integrating factor. Go back and check your because you got to have that first solution in this list somewhere. Okay, it's got to be there.
And it's always going to work out the constants in front of y sub 2.
Always,
Okay.
always, unless you make a mistake.
Mm-hmm.
Okay, unless you make a mistake, it's got to be there. All right, that is reduction of order. On the homework, let me show you what they do on the homework, because I just want you to ignore it. If I had figured out, if I could have figured out a way to ignore these directions, they tell you to do, tell you to do this mess right here. Just ignore that. Just ignore it. They're asking you to memorize something and do it that way. Just do your method the way that I do it, and it'll all line up really nicely. Okay, so just ignore all those directions.